Let's practice using Newton-Rhapson in this example over here. The example asks me to find an x-intercept on the positive side of the x-axis. In other words, I'm looking for this point over here. Now we can see that that is somewhere between 2 and 3 here, but how would you have known this? We first need to test when my graph is going to cut the x-axis. And you can see that to the left of that point, I'm going to have negative y values. And to the right of that point, I'm going to have positive y values. So if I can test so that I can see where I'm going to have negative and positive y values, I must have cut my x-axis somewhere between those two values. So let's do that first. What I'm going to do is I'm going to check what would have happened when x was 2. If x was 2, then y is going to be equal to 2 squared minus 2 minus 5. Well, you can see very easily that that is going to come to a negative number, which is minus 3. Let's test what would have happened if x was equal to 3. Then my y would have been 3 squared minus 3 and minus 5. And now you can see that y was going to be equal to 1. In my first answer, I had a negative y value. In my second answer, I had a positive y value. If my y value changes from negative to positive, I must have crossed my x-axis. So I can assume that I've got an x-intercept somewhere between when x is 2 and when x is 3. So if I'm working on the interval when x is an element of 2 to 3, then I need to make my first guess. Well, what's halfway between 2 and 3? I'm going to say that my first estimate is going to be when x is going to be 2, 5. Now I'm going to set up my Newton-Rhapson formula. But in order to do that, I have to have the derivative of my function. The derivative of the function of y in the variable x is going to be given to me by 2x minus 1. So if I want to get my second estimate, I'm going to say that I'm going to put in my first estimate minus the function with my first estimate all over the derivative of my function at that same estimate. Now what I'm going to do is I'm going to show you how to do this so that you can plug in your first estimate, and from then on your calculator does the rest. So to get to my second estimate, I'm going to get my first estimate, and then my function was a1 squared minus a1 minus 5. And that is the original function. The derivative of my function was given to me by 2 times by my first estimate and minus 1. Now I told you that your first estimate is going to be 2, 5. Listen to me carefully because I'm going to tell you this without writing it down. Take your first estimate and type it into your calculator and press equals and answer. And then press minus. Put in a fraction. Now press answer squared minus answer minus 5, all in the numerator of your fraction. Go down into the denominator and press 2 times answer and minus 1. From now, it's almost like magic. Every single time you press equals, your calculator is going to come out with your next estimate. Carry on pressing until you can see that those decimal places stop changing, and you would have got your final answer. When you finish pressing your equals and your decimal places remain the same, then you're not going to have an estimate anymore. You're going to have your final value for your x-intercept. And in this example, if I round that off to 4 decimal places, I'm going to find that my final answer was 2,7912. In other words, we found the exact value for x when y was 0, where I had put my red cross. This value here is 2,7912. Now this was quite an easy answer, and you'd probably say to me, but you're wasting your time because we could just have used the quadratic formula. It's not always going to remain this easy, but this is an easy one to start with so that you can understand the concept of how to use Newton-Raphson effectively.